Welcome back, everyone. If you're a doctoral student or researcher, you know the term big data gets thrown around constantly. It's like the ultimate business buzzword right now, right? But today, in this explainer, we're completely stripping away the hype. We're going to look at big data for what it really is, a highly rigorous, transformative quantitative tool. We'll be drawing directly from Professor Fiznik Marina's 2026 academic framework on qualitative and quantitative methods. So let's jump right in and decode how massive datasets are literally rewriting the rules of economic analysis. Here's the roadmap for today. We're going to start by defining what big data actually is, then look at how it's transforming decision-making, where all this data actually comes from, the privacy regulations we absolutely have to navigate, and finally, the real research and methodological challenges you'll face. So, part 1. What is big data? Let's pin down exactly what we mean when we use this term in a serious academic context. At its core, big data involves data sets that are just so massively large and complex that your standard off-the-shelf processing software simply chokes on them. It just can't handle it. But, it's not actually just about the sheer size. It's really about the explosion of digital platforms and smart systems. Because of this scale, we can suddenly uncover these deeply hidden economic patterns that old-school, smaller sampling methods would completely miss. We're no longer looking at static snapshots from the past. We are analyzing dynamic, real-time processes as they actually happen. To really wrap our heads around this, the academic literature, specifically researchers like Provost, Fawcett, and Schmaleli, breaks big data down into 5 distinct dimensions. We call them the 5 Vs. You've got volume, which is the massive amount of data; velocity, how lightning fast it's generated; variety, meaning the messy, diverse formats it comes in; veracity, which is all about the data's reliability; and finally, value. And here's the kicker. Effectively managing all 5 of these dimensions is the absolute prerequisite. If you can't manage them, you can't turn raw, chaotic data into actual, useful knowledge. When you think about how all these dimensions intersect, it's like a giant puzzle coming together. While our core focus is on those foundational 5 Vs, expanding this framework takes an overwhelming tsunami of information and turns it into a structured, workable system. It really goes to show that just hoarding data is only step 1. Making that data reliable, processing it at speed, and extracting real value, well, that is where the true scientific rigor comes into play. Moving right along to Section 2, Transforming Decision-Making. Let's see how this framework becomes a literal superpower for strategic choices. Think about it. For decades, major strategic business decisions were basically made using executive intuition mixed with a little bit of historical data, sort of a best guess scenario. But we are right in the middle of a massive paradigm shift. Organizations are sprinting away from those intuition-based choices and moving toward highly accurate, data-driven strategies. Today, when you have access to real-time market behaviors, relying on your gut feeling isn't just a little outdated, it is a massive competitive disadvantage. And what's powering this shift? Really advanced analytical methods. We're talking about heavy-duty predictive analytics and machine learning models that can actually forecast market trends before they even happen. Leading researchers like Varian, McAfee, and Brynjolfsson argue that when we integrate high-frequency alternative data into traditional econometric models, our ability to react to economic shifts and manage risk just skyrockets. It's a total game changer for macroeconomic and financial analysis. Okay, that brings us to Section 3, Sources and Collection. Basically, where does all this massive scale of data actually come from? In our hyper-connected digital economy, data is constantly flowing from all sorts of sources. First, you have transactional data. Think banking records, electronic payments, point-of-sale systems. That gives us incredibly granular details on financial behavior. Parallel to that, you've got online platforms and social networks pumping out a continuous stream of information on consumer preferences and brand sentiment. These high-frequency sources are absolute gold mines for real-time insights. But obviously, you can't just sit there manually copying and pasting millions of rows of data. To collect this stuff at scale and without breaking the bank, researchers rely on some pretty heavy technical lifting. First up is web scraping, which automates data extraction straight from websites. Then we use APIs, or application programming interfaces. These act like a direct, structured pipeline hooked right into digital platforms. They are essentially the unsung heroes of digital research. And when you look at the entire technological ecosystem in action, it's honestly fascinating. Everything is perfectly interconnected. Human users, mobile devices, massive cloud storage facilities, and AI analytics, they all feed into each other. It creates this continuous, seamless loop of data generation, collection, storage, and algorithmic processing. That loop is exactly what makes the modern digital economy tick. But of course, there's always a catch. Let's look at Section 4, Privacy and Regulations, because we absolutely have to talk about ethical data usage. The thing is, gathering all this data systematically is technologically pretty easy nowadays, but doing it responsibly, that is a massive hurdle. When you're tracking high-frequency consumer behavior and financial transactions, you are handling incredibly sensitive personal information. Ensuring airtight data security and maintaining strict ethical boundaries isn't just a nice-to-have, it's a mandatory pillar of modern research. Well, unless you actually enjoy trying to explain your methodology to angry international regulators. This is exactly why frameworks like the GDPR exist, setting incredibly strict international standards for personal data protection. Academic studies by folks like Kitchen and Wamba highlight a really crucial point here. Sticking to GDPR principles isn't just about ticking compliance boxes or avoiding massive legal fines. It is literally the foundation of your credibility as a researcher. Frankly, if your data collection methods aren't ethical, your entire research output is invalid. Full stop. Finally, we reach Section 5, Research and Methodological Challenges. We're getting to the narrowest part of our conceptual funnel now, zooming in on the actual analytical friction points you're going to face. Look, utilizing advanced algorithms is incredibly exciting, for sure, but it demands a ruthlessly critical eye because of some deep analytical pitfalls. You'll constantly battle bias in datasets that aren't truly representative. You'll wrestle with overfitting, which is when your shiny new machine learning model memorizes the random noise in your data instead of finding the actual underlying trend. And maybe the biggest headache of all, the severe limitations on proving causality. Just because two massive data trends happen to correlate absolutely does not mean one caused the other. So this brings up a massive question about empirical validity, something you always need to ask yourself when designing a study. Are we actually measuring a real economic impact, or are we, just blinding ourselves with our own sophisticated analytical tools? It is surprisingly easy to build a complex predictive model that looks absolutely amazing on a dashboard, but completely and utterly fails to reflect reality in a real, dynamic market. I want to leave you with a final, slightly provocative challenge for your own doctoral work. When you're studying big data, how do you actually handle endogeneity? Think about it. Do firms perform better because they invest heavily in big data? Or do highly successful firms simply have the extra cash lying around to buy those expensive big data tools? That's the trap right there. I challenge you to propose an alternative research design that solves this endogeneity issue and pushes the boundaries of what quantitative research can truly prove. Thanks for tuning into this explainer, and I can't wait to see how you apply these frameworks to your own work.